So now we're going to take a look at evaluating logarithms, and there are a couple of different ways you can do it. The first method we're going to look at is evaluating mentally. So when you have, and that works out when the value that you're evaluating actually it's a multiple of the base. So let's just take a look. For log base 4 of 64, you can imagine 4 times 4 would give you 16. And then times another 4, that does not like a 4, bad 4, will give you 64. So we can see we multiplied 4 by itself 3 times, so log base 4 of 64 is equal to 3. We can do the same thing of log base 3 of 1 over 27. So I notice that this is a fraction, much smaller than this, so we must have a negative exponent. So I would imagine it's 1 over 3, right? So log base 3 of 1 over 27 would be, so we try to think of what exponent that we need to, how many times we need to multiply 3. In this case, 1 over 3, we need to make sure it's negative later. So it's 1 over 3 times 1 over 3. That'll give us 1 over 9. And times 1 over 3 again, that gives us 1 over 27. So we can see that log base 3 of 1 over 27 is going to be negative because we see it was inverted. So negative, and we did it 3 times, so negative 3. So another way to evaluate logarithms is to use just a common log. So the most common log is the base 10 log. And in your calculator, you're going to see a log function. And whenever you see log without a number, it's assumed to be base 10. So the other common base you'll see is e, and that's going to be natural log, and I'll talk about that in the next slide. But and base 10 logs are easy because you can really just count up the number of zeros in order to get the answer. So for example, y equals log of 1,000 is equal to 3. So it's equal to 3 because we have 3 zeros, right? And log base 10 of 1 million, we count up the number of zeros, that'll give us what? So hopefully you said 6. So very simple. And the other type of log that actually, before I even get into the other type of log, let's just talk about how to do this with a calculator, because I did some simple numbers, but what if I had log of 321 or log of 123? What do I do with that? So I would then have to use a calculator or a table if it's not like a perfect power of 10. So you could just press log, you would write the given number in the parentheses just as you see here, and press enter, and then you're going to get your answer. So what I would like you to do is practice getting log of 321 and log of 123. Practice that on your calculator, see what you get. So my final answers are 2.50665 and 2.0899. So I went out to 4 decimal places, and keeping 4 decimal places helps us with rounding errors later on, because a lot of times you're going to use this as just one step, and we want to keep multiplying or dividing, so we do need to keep as many decimal places until the very end. So hopefully you were able to follow along just fine with your calculator. The final type of logarithm that we can work with is a natural log, and you also have a natural log button on your calculator, so it looks like ln for, I guess, log natural. I'm not sure how they came up with that exactly, but you would use it in the same way that you did with the logarithmic function, the base 10 log. Well, it is a logarithm function, so you'll just press ln, then you'll enter the value into the parentheses, just as you see here, and then you'll press enter. So we can also practice. I want you to go ahead and practice getting a natural log of 500 and a natural log of negative 500. Okay, so at this point, you should have gotten 6.2406 for the first one. For the second one, you should have gotten an error. And let's think about why we got that error. So remember, we can rewrite this. The natural log, we know the base is really e, although we don't see it. So e raised to what power? will give us negative 500. Well, E, it is a positive number. And you're trying to think, how many times can you multiply a positive number by itself to give you a negative number? Well, it's just not possible, right? We're breaking all kinds of math laws if we do that. Not definitely a real number anyway. So what we're going to do for this one, it's going to be error. Later, if we do more advanced math, and maybe we use some imaginary numbers, it may be possible to then evaluate this. But whenever we're dealing with real numbers, this is not possible. You're going to get an error. So that's why right now we're going to make sure that what we have in here, right, especially for natural log, we're just going to keep it positive, and for all of our logs right now, just to keep things simple.